as Ronnie Trommer is going to be taking this session, and I will be back tomorrow. So I'll hand you over to the capable hands of Ronnie Trommer. Thanks, Ronnie.
Thank you. So, yeah, we have our last session yesterday with events and traps. Did you made any kind of or did you encounter any kind of problems yesterday, or did you have any questions we might want to clarify before we digging into another topic in the joy of SNMP and getting performance management topic going?
Hi, Ronnie. It's Eric.
Yeah, hi, Eric.
So yesterday we quite finished the exercise 3.1. Not so we stopped, right before generating an event and a clear event to clear it. So we were quite at the end of this lab. So here we are. I think this status is more or less the same for all the students here. So here we are. So honestly we didn't play yet with the, how do you call it, the alarm reduction key, something like that. So I didn't play with it yet. But globally, I understand the mechanism, but did not play yet with.
So just to so you were able to send the trap and you were able to translate it to a trap which comes from that camera map.
Correct.
So you don't have that unknown enterprise trap anymore. So it's like a formatted trap, so to speak. But you haven't really played around with like creating an alarm out of the event, like that alarm raise and clear topic. So that is a bit of outstanding, I would say.
Exactly. That's the status, yes.
Okay.
So we'll carry on with that tomorrow, Ronnie.
Yeah.
Anyway.
Okay. So then we have kind of an idea where we can start off with that tomorrow, because we digging into a totally different topic and wouldn't be. I think it would be helpful to just know where we need to take off tomorrow. Awesome. Okay. Great. So then we talked today a bit about performance management, which is a bit a different space in the monitoring domain. I made a few slides which are also in the Session5 repository in Greg's GitHub repository. So if you sync your fork, you will get the slides I'm showing to you in a minute. So don't worry about it. So you get all the slides in that GitHub repository. Everything I'm presenting is in that Session5 directory in that GitHub repo. So if you don't have that yet, it's not a big deal. What I would like to give you first is kind of a bit of an overview about what performance management is and what components are involved in OpenNMS, and to give you a bit of an understanding about what this exercise and this session is about. So I'm going ahead and share my screen. Do you see that slide, performance management?
Yes.
Okay.
Sorry. Ongoing.
Yeah.
No.
Not
it's ongoing.
Yet.
No, not yet. It's loading.
Rami, but it should be also among the materials that you shared, right?
Yeah, it's the PDF is in that Session5 directory.
But in Session5 there are many directories that is configs
It should
images.
be like there's in the Session5 directory. It's called Performance Management Introduction. It's a PDF.
Just to see, because I don't see it.
You might have to synchronize the repository.
So far, Ronnie, we can see your screen, but it's a black screen.
Yes.
There, make it.
So it's nice, but not what you expect.
Mm.
Then I make. Wait a second.
You probably have several screens, I guess.
It's a second one, yeah. And you see that one?
Yes. Now you can see.
Okay. So, you still see it?
Yes.
Okay. So it's all about performance management. So what we are talking about in performance management is technically everything you would like to know from a system or device about like utilization, saturation, errors, any kind of metrics you would like be interested, but not like in just like the current state. You would like to see these metrics over time to get an idea about like a behavior of a system. So that's why you want to probably look at something like time series graphs to see how a system behaves in certain circumstances and with certain workloads. So that is kind of the topic or the use case why you would like to dig into the topic of performance management. In OpenNMS, you have various components who deal with that topic. So we have, yesterday we talked about events, which is a core piece in OpenNMS, and OpenNMS can take events from different protocols and sources like syslog and traps and convert that to events. In performance management, it's a bit similar. We have a daemon in OpenNMS, which is called collectD, and it turns metrics from various agents into a data collection set and persists it on the disk. And it can also talk to various protocols. What we put a little bit out of scope in that topic is everything about like availability and latency. So latency, if you want to, it could be a topic for performance management as well, but we separate that out for a different session, which is more about like service assurance or service monitoring that will cover the topic for latency. That is not a part of that session. Any topics or any questions about it or anything unclear?
When you say that
Yes.
latency, availability are not in scope,
just for that session here.
yes, as far as I understand, for example, availability is an indirect measure, no?
Yeah.
Okay.
Availability is. I think it's important that we have that kind of clear understanding what OpenNMS means with availability. In OpenNMS, you can run tests against services. Like every 5 minutes, you make a ping or you make a REST call or querying some SQL statement from a database or whatever. And that is basically like a test, and that has just a state up and down. So the test failed or the test passed, and we measure also how long was the time to perform the test.
Okay.
So that is taking care of the polar daemon in OpenNMS, which is a different component, and therefore we don't consider that here.
Okay, no, okay, thank you. I understand.
So
so we are focused on collectD.
It's collectD. It's collecting performance measurement data from agents, various agents. We focus today on just on SNMP.
Okay.
And getting metrics from there, persisting it on disk, and the visualization of it. Okay. So how does it look like in OpenNMS? Just to give you a bit an idea of the architecture. So we have OpenNMS Horizon, the core system, which is like the server you install, that's when you make the Docker Compose up, and the Horizon service comes up. That's what we call the core server that had all components in it. And for performance management, we have a way to persist time series data. OpenNMS is a pretty scalable platform. There's not just one time series implementation you can use. You can pick a few of them. By default, if you don't do anything, you have a RD tool as time series storage. That's basically where all the time series measurements end up on your file system on a disk. And you can also switch to different ones like Cortex, Mimir, and Newts. And you have also a possibility to send performance metrics upstream to Kafka, which might be the one which you are interested in to forward metrics to a different system. So RD tool is the easiest one because it's just creating files on your disk. It's very low maintenance, has some so it's not very complicated. With Cortex, Mimir, and Newts, you're building really dedicated clusters and very scalable systems to store a lot of time series metrics over time. So in this session, we just use RD tool for now. If you replace RD tool with something else, for the user, it doesn't really look different. So they can use the same visualizations. It's just like the back end works differently and has different performance characteristics. In the core system, collectd is the daemon who is just responsible for collecting performance metrics. So there's a specific daemon with their own thread pool, which is just all about collecting performance metrics from various agents. And with OpenNMS, it comes also all the protocol. So there come a lot of protocols which are implemented like SNMP, JMX, JDBC. So we support a few protocols out of the box, and you don't have to program them yourself. You just have to configure them. So you have to tell collectd what is the agent you want to talk to and what are the metrics fetch, and depending on the protocol you are using, the configuration looks a little bit different. So in the SNMP context, you're talking about like MIPS and objects, OIDs. In JMX, you talk about which mbeans you want to fetch. If you want to make an XML or a JSON data collection, you have to figuring out what are the key value pairs for metrics you want to collect. So depending on the protocols, the configuration looks a little bit different. We are focusing today just on SNMP, just give you an introduction on that topic. When you come in with a minion, then the architecture looks a little bit different. So instead of having the OpenNMS core system making the communication to the agent, the minion will take that over. The collectd part is still on the OpenNMS core system. You can see the minion a little bit as a proxy for the underlying protocol. So that gives you basically the ability to deploy a minion in an isolated or remote network and let them talk the protocol specific communication to the agent. And between the core and the minion, there's just the message broker communication. So that makes it a bit easier to deploy a minion in a remote location. You don't have to open all the network protocols and ports from a core system to a remote location. So that makes it a bit easier to get access to management agents or in remote networks, which are not so easily accessible. Any questions on that? Comments? Okay. So how do you look at the performance metrics? So there are like two ways to look at performance metrics. One is natively in the web UI. which is kind of the templates or the graph definitions are coming from the RD tool, which is a pretty old, pretty mature open source project to store and visualize performance data. And we provide you like with a possibility to define your graphs in RD tool definition. It's a part of the configuration in OpenNMS that is just about like how these measurements are visualized. And the second one is using Grafana, which is a dedicated dashboard tool for performance metrics. It uses the REST API from OpenNMS Core. So what you basically end up doing is you install Grafana, you install a little plugin for OpenNMS, which talks to our REST endpoint, and that gives you the ability to visualize and building dashboards from these metrics in Grafana. Any questions on that? Okay. So in the core system, what we have seen yesterday, so you played a bit with our event bus. Collect D is another daemon which is also connected to our event bus. So that means it is able to consume and produce events in the event bus. So if you look at Collect D, it does, beside collecting the performance metrics, it does also something like thresholding. For example, you want to apply like a basic thresholding on a metric. For example, like disk usage, you want to create an event when the disk gets full, or the bandwidth of a network interface is going to exceed. Then you would like to generate events, and for that use case, Collect D can create events on our event bus. It would be a similar thing what you have seen yesterday. So the event, what Collect D creates is like a high threshold exceeded event, and there will be a high threshold rearmed event when the system goes back normal. So you have this kind of event driven state where you can say also create alarms out of it with the exceeded and raised event. So it's the same mechanism you have seen yesterday. So there's that event handling and alarm generating is basically used from all our daemons in a similar way. So if you have a bit of an understanding how alarms are generated, then you will quickly understand also how Collect D creates the alarms when high thresholds or low thresholds were exceeded, and how that works. But it uses exactly the same mechanisms. Any comments, questions? So as I've explained a little bit before, so we have various, Collect D has many protocols which it supports by default. So we have the SNMP collector, we have XML collectors for getting metrics from structured data from the file system or REST endpoint, or wherever an XML or JSON document can be provided. We have JMX collectors, and there are a few more, and we can also extend OpenNMS to other protocols as well. When you see things like plugins, then basically what happens is another collector protocol gets implemented. But in general, it's all executed or scheduled from Collect D. So Collect D schedules like every 5 minutes a collection for a certain protocol, fetches the metrics and persists on the disk. And in case when it's configured, evaluating thresholds on it. So yeah, the exercise today is all about SNMP for now. What do we need to make SNMP work? So first of all, we need the ability to talk to an SNMP-enabled device. So SNMP is an agent running on a device. By default, it is accessible over the UDP port 161, and you need technically credentials to talk to the device. And there's another topic, which is how a system is identified, which is called system object identifier. It's basically giving the SNMP management system an idea what capabilities does that device really has. So in OpenNMS, you have a web UI where you can configure SNMP in general. I'm not sure if you have all seen that, but that's basically how it looks like. So you go into the admin section, and then you can configure the SNMP credentials for a device or for a whole set of devices, depending in which network range it is deployed. So you can set communities also like on an IP range base. And another important topic is the location. If you have minions deployed, you need to make sure that you pick also the right location. So that means if you have two locations, location A and location B, you can configure different SNMP communities depending on where devices reside. Any questions on that topic? Okay. So the system object identifier is an important concept in SNMP. It gives you basically an idea or gives the management system an idea what type of device do we have, what is the manufacturer, or is it a router, is it a switch? So it gives a management system a clue what capabilities a device has. So in this case, like that in SNMP, you have like a convention about like that 8072. They are like enterprise MIPS, so vendors like Apple or HP or whoever build devices can create an can register an enterprise ID, and then they build like a own tree of metrics they want to provide. So they get basically their own namespace for metrics. And these metrics need to be described somehow, and that is where the MIP comes into play. So that's, you played already yesterday a little bit with the TV camera MIP. So they had also kind of an own registered enterprise number, and they built their own tree of metrics and traps to implement monitoring functionality. So basically that gives the management system an idea of what we have in front of us. So in this case, if you query like the system object idea, it tells us like that is an net SNMP device, and the number 3.2.10 means net SNMP is installed on a Linux system. So that's basically what that means. Any questions on that or comments? For OpenNMS, that system object ID is really important because it defines basically what metrics can we collect from a certain agent. So that is a very, it's a key component in the whole SNMP data collection. So if that is missing, that is a problem for OpenNMS. So because it doesn't know what metrics can we collect. So the system object ID is an important piece. How does it look like in OpenNMS when you provision a device? I think you all did like the provisioning in the session before. So if you have SNMP enabled and OpenNMS can talk to the SNMP agent, what happens is our provisioning system will try to get the information from SNMP and populates it in our database, and you will see that here as the SNMP attributes. And the system object ID is part of that process. So it gives you also the location, the IP interfaces, SNMP, like the physical interfaces, which is called here SNMP interfaces. That all happens during provisioning. So provisioning plays also an important part to make all that happens, because it's like a first discovery of a device, and what is the SNMP agent information we can fetch from it. Any questions on that?
So here,
Yes.
the availability of SNMP agent is at something like 3 p.m., starting from 3 p.m. Or is it the availability of OpenNMS talking
No,
to?
it's basically when I provision the device, and we get the first contact of the SNMP agent. So
okay, so that's the first polling
exactly,
done
yes.
between OpenNMS and SNMP, right?
Right.
Okay. Okay.
So there are a few things. So when you provision a device, that's what basically happens in the background. So it will try to discover these services. That's what Polar D takes care of, to see if the device is available on the network with ISNMP, and it runs also an SNMP test to figure out if the SNMP agent is running. So it runs a probe against the SNMP agent. And that is what you see here in that availability topic.
Okay, thanks.
May I ask a question about the GUI?
Yes.
Times in the GUI. So in the availability, ISMP and SNMP, I see timestamps without time zone. In the recent event, time zone is added. So should we assume that events in the time scale in the availability is without time zone, or it's the same time zone as events?
It's the same time zone as the events, because they drive basically the whole availability calculation.
Is it possible to get rid of the time zone, because it's a bit confusing?
I think you
just
can.
show server console or server time.
There is a way to configure the representation of the time zones in a property setting.
Okay, I will look for it. Thank you.
So, but it's we can make a note about it. So time zone configuration, and then we can. So there's a property in OpenNMS where you can define what the format should look like. I think that's just the default here is just with the time zone as like an ISO 8601 format by default. So, but you can change it. It's
okay,
configurable. Yeah, the important piece again for collect D and performance data collection is the system object ID. That tells basically what that is basically how OpenNMS determines what metrics can we collect from that agent. If you click on that SNMP service, so what I basically did is here, if you click here on that SNMP service, you see some details. And you will notice two pieces. One is like the polling piece here. That is our Polar daemon. That is all about like testing the availability of the SNMP agent. Is it responding or not? And the second column here is the collection. So you see on that SNMP service, we have a collection package associated with that service. And we wanted to use the collector class as an SNMP collector.
What's the unit of the collection interval? Is it in a second or milliseconds?
That is milliseconds.
Yeah. Okay. Yeah.
So,
that's 5 minutes so it means 5 minutes by default here.
Exactly. Yes.
Okay. Okay.
So what you see, so we basically use that SNMP service here for two purposes, and that is tricky. That's not very easy to understand. That's the reason why I would like to highlight that very. So the SNMP service name is used in two pieces. One is for like the SNMP monitor to test if the service or the SNMP agent is still available. And what it does, it checks like that system object ID. It tries to fetch that OID here. If the agent responds to that OID, then OpenNMS knows SNMP service is up. That's it. There's nothing about like fetching the disk usage or CPU usage from an agent, right? So as the Polar daemon is just about figuring out, is the SNMP agent alive or not?
So it means that the OpenNMS will send a specific trap OID to the SNMP agent. It's a specific trap,
don't
right?
send a trap. We're making a GET request, basically. The trap is when the agent sends us information.
Yes.
And when OpenNMS, the Polar, makes an SNMP GET request, that's when you basically make SNMP GET or SNMP walk on your console. Then that's basically a similar thing what our SNMP Polar does. It tries to figure out, is the SNMP agent still alive?
Okay.
And he needs to make a probe somehow against the agent. And if it responds to that OID, which is the system object ID in this case here, that number here represents the system object ID. We use that basically as a probe to determine if the SNMP agent is still alive. And that corresponds to the availability here.
And this SNMP GET request, is it a blocking request? So I mean the SNMP agent should answer straightforward after receiving the request, or is it responding in background? Let's say
it's in background.
Okay.
So that's very.
So it's asynchronous, right?
Yeah.
Okay.
So and that SNMP service is also used in collectd. So collectd will look up in his configuration and sees, okay, for the SNMP service, somebody configured a data collection, and I have to use for the SNMP service the SNMP collector, and I need to fetch a certain set of metrics every 5 minutes. And the combination about like the IP address and the service, so the service is on an IP address that gives collectd basically the entry point to the SNMP agents. How do we need to talk to the SNMP agent? It is based on the IP address with the SNMP service.
So here we don't have from that dashboard, we don't have the list of the metrics we want to collect, right?
No.
Okay.
It's just telling you basically what OpenNMS is doing with that service. So what do we have configured for that SNMP service? What you see is basically, okay, I see we have an SNMP monitor running. It's configured in that with that OID value. And we have a data collection enabled with the SNMP collector, which needs to do a collection. We talk about that in a minute. And we have the thresholding enabled. So
excuse me, Ronnie.
Yes,
I see on the right part of the screen, I see Polar service parameter together with collect service parameter. You explained already that Polar is a different stuff, but what I see that is the object identifier consists with the sysobject ID. Is it correct? Yeah.
Yes.
So the first action that is performed is to query sysobject ID, having back the result, and then starting to walk through the MIP driven by the result of the sysobject ID. Is it correct?
So we have here two independent systems. one is like figuring out if the SNMP agent is alive. That is what Polar D makes. He makes that GET request. If there's something coming back, service is up. And on the second part, we have collect D.
So the service is up depends on, sorry.
Yeah, the service is up depends on the Polar.
And the Polar, what does it call? The object identifier is the sysobject ID.
Yeah.
Okay. So it gets back the sysobject ID result. That is a certain object identifier that indicates the type of the equipment. And then is able, then it declares that the service is up. And then it goes through all the branches that are driven by the result of sysobject ID.
Yeah, we come to that now. So,
okay, sorry to anticipate.
Yeah, no problem. Yeah, but it's important to understand, like, that's just about like, is the SNMP agent alive for the Polar? And we use the same service for data collection, which is about like what object or what metrics do we want to collect?
Yeah.
So, and that is where they called, so when you install OpenNMS, they called that collection here, that it has a name for where all these OIDs or MIP object IDs are defined. They called it just default. It's not a very nice name, but the collection set is just named default. So
okay.
So that is important. And what you don't see that in the UI, you have to go into the configuration. So what is associated with the default collection, you see here is like, they call it like they group a few OIDs. And then you see kind of what metrics you collect for that collection.
Okay, but so what is meant with the default? Is all the metrics that are discovered?
It just means like they just called it default because they want to ship something out of the box, right? They don't. So when you install OpenNMS, you get all these metrics already from various Cisco boxes, HP, whatever. So there's a big list of OIDs already pre-configured in OpenNMS. You will see that if you go into the into the configuration file, and they just had to make a decision about giving that whole collection they provided a name.
Okay.
I mean, it's not a nice name calling it something default, but
okay.
It just said to pick one. And what in that, and you will see that later if we go into the configuration files later on.
Okay.
You will see that. That means just like there are like all the OIDs we can collect from that agent are specified in that configuration file. So you see now here, like that is an example for like disk metrics. So the disk metrics are specified in that 136.121.25.23.1.2. So that's basically a table.
Yeah.
For every disk, and then you have various attributes like the type, description, the size, how much is used. So that is what we tell now OpenNMS to collect from that agent and persist it as time series metric. And the important piece here, what you see below, is like that system definition.
Okay.
So we use the system OID discovered from provision D, what we have seen on the first page on that node detail page. We use that system object ID to tell you, okay, if you have a device with that system object ID, include this group of OIDs.
Okay, so this is the reference.
That's the reference to tell OpenNMS if you have a system with that OID, try to fetch all these metrics, right?
Okay.
It's very indirect, I know, but it's so there are a lot of pieces coming here together, but it makes it very flexible because you only specify that OID once, right? And every time you provision a new system, you don't take you don't have to do anything with the configuration anymore, because you basically configure it on a device class, so to speak. So every
this
time
include group can have more rows. Include group is only one room, or you can add many?
There can be many.
There can be many. Okay.
So you will see such a group, such a group for like for disk. You will see a similar group for CPU usage, memory, network interfaces like in octets, out octets. So you will see many groups like that.
Okay.
Can collect D apply some arithmetics over collected data and generate new metrics like storage size and storage use?
That happens.
Probability metrics, I can get storage free, for example.
Collect D is really about fetching the raw metrics and persist it. When you evaluate thresholds and when you visualize it, then you have to make the arithmetics.
Okay.
That's the place where you can apply arithmetics, yeah. To make, for example, like if you want to have it in percent, or you want to make like sometimes another use case where you need arithmetics is in SNMP, there's no way to give you like float values. They just have integers. And if you want to have a float metric, they just do something like they multiply it by 100 or something like that. And when you visualize the metric, you have to divide it by 100 to have a float value. So you will see things like that.
Thank you.
Yeah, but it's a very good question. So arithmetics are on the threshold evaluation and on the visualization. You have to apply them. Any other questions? So just to recap a bit in trying to put that in a picture. So we have the system object ID, which is assigned to a node coming from provision D. We have the SNMP service, which is detected also by provision D, or you assign it yourself manually. And to that SNMP service, we have a collection package. That collection package is referenced on a collection set, so to speak, which we call default. And in that collection set default, you have all the OIDs and the system definitions. Just to try to get that a bit into how they relate to each other, kind of. So, and that's the place where we can go into our exercise and try to fetch something from OpenNMS. And I can show you that here in the environment, or we can go through it together. So in that exercise 5,
Ronnie?
Yes?
Sorry, just before we jump into exercise 5, I want to suggest to people that they modify the version of OpenNMS that's in your Docker Compose from 32.06 to 32.05, because they will have already downloaded that. And if they download 2.06, it's going to take a while.
Yeah, when I did that exercise, I was on 32.06, yeah.
Yeah. So when we come to this, if people just change that back to 32.5, it'll save you a lot of time waiting for the images to download.
Yeah, I didn't know that you were one version earlier. I avoided to go to 3301, so
good. I'm very glad about that.
Yeah. So we are just a minor release way. So, but we can do that just here. Give the video back. So share window. just share the entire screen. So what you said is session 5. Do you see my screen, by the way? Just to make sure.
Yeah. Yes.
Okay, good. So there's a stack, and that is the compose file. So what we can do here is, you changed it already.
Yeah, I changed it on the example.
Okay, so if you synchronize your fork of the repository, then you should get the correct version.
I don't know if you can do anything about it just at the moment, Ronnie, but could I also suggest you could change your screen from to black on white, because for the recording it'll show up a lot better.
Settings, somewhere here, appearance, like default. So better?
A lot better, thank you.
Okay. So we are on this. So so the exercise is about like we have a SNMP device which we can provision into OpenNMS, and we would like to fetch 3 metrics and collect 3 metrics from that agent. I've just picked like the metric load average. Anyone familiar with the load average metric, what it means, or anyone an idea?
That's the CPU load? No?
Yeah, basically it gives you like, it's a high level metric to give you an idea how utilized the system is. And it takes in account like the CPU queuing and the disk IO queues. So it gives you kind of an
combination of both. It's a combination of both.
Yeah, exactly. Yes. So CPU usage takes in account, and also input output like disk and network, and when you wait on certain things. So it's an aggregated metric, and it gives an idea how utilized the system is basically. And you can fetch that metric is generated in 3 values, like a 1-minute average, a 5-minute average, and a 15-minute average. So that's why you have 3 metrics here. And it's just like depending on how like the system is like, if you have like just like usage spikes, then the 1-minute average will show you that. The 5 and 15-minute minute average just flatten that out.
So Ronnie,
Mm-hmm.
here in your SNMP work example, I can see that we are polling, we are sending the request to the port number 1610 in localhost. I would expect 161, in fact. Why
Yeah, so
is it? Yeah.
Mm-hmm. I can explain that. If you look here in the compose file into the Linux agents, do you see that line? So what basically happens, to give you the ability to query these SNMP agents from your local notebook, I published a port on your host system, and inside the container, it's still the port 161. So inside the Docker network, it's port 161, but on your local system, it's 1610. So that way I can expose multiple SNMP ports on your local host without having a port conflict. If I would use like 161 here as well, I could only expose one Linux agent port to your local host notebook. But that way I can give you access to every Linux agent's SNMP agent and just using a different port. But inside the Docker network, it's always 161. So, and that is also what OpenNMS will see.
Got it. That's clear. Thanks.
Yeah. So, and every device has its own IP address, so it looks a little bit like a dedicated server. So that's the reason why you don't see port conflicts happening. So one like 33 is 161, 34 is 161. So that's basically how OpenNMS will see the containers from his perspective. Okay. So let's go through that exercise. I think we can go through that exercise together first to give you kind of an idea.
Just to say,
yes.
if you're doing this, you probably don't have NetSNMP on your PCs, so you would have to log into one of the containers to do the SNMP walk locally. In which case, obviously, it's going to be not localhost 10.1610, but
Yeah,
localhost 161.
If you don't have, so yeah, that's so you don't have SNMP installed on your local systems, right? Then we can use just like the Carafe shell and use the OpenNMS one. It's not a big deal. Okay. So so okay, so I'm still on 3106, but that's not a big problem in my case. So do you see the terminal as well? Okay. So yeah, we are on that directory for the stack. You can check if you have anything running. So in my case, that stack is already up and running. Okay. Docker compose down.
I'm afraid that from HP network doesn't work. You have to change the network every time. You have problems. I don't know if my colleagues also, because I'm the premises.
So what doesn't work, or what is your problem exactly? So you cannot run like the Docker compose up command, or what happens?
This is my problem. I trace it.
Just share your screen if you want to. Is
Yes.
it possible? Yeah.
Yes, of course. Just to know how to do.
I mean, if other colleagues had the same problem, that might be fundamental.
You see?
Yes, I see. Yeah.
Yeah. So this is.
Yeah, you are in the stack directory. Okay, got it. Yes. So it's not running. So that looks a little bit like your Docker daemon is not running, or your
yes.
user,
Oh, sorry, Docker desktop. Yeah.
You have to spin up Docker desktop.
This is very silly, stupid thing, but I hope that.
Yeah, it's a weird. It tells you basically that it cannot. It cannot connect to the Docker daemon on your.
Yeah, but it should start. No.
It might take a while because there's like
take a while. Okay. Sorry for. Okay.
No
I
problem.
leave the screen and I come back afterwards. Tell me.
So there's some point. There's I think a little icon on the somewhere down.
No, here is not.
No, I don't see an icon down there.
Just
what happens if there's no error message or there's nothing happening?
No, nothing happening. So
it sometimes takes a while to come up. So just give it a minute or two. If you click on the Docker desktop app, click on the app.
Yeah.
Oh, now it's coming. Yeah.
Yeah.
It will not start. There is an error.
Yes.
Yeah, there's on the.
But now I hope that.
It was running yesterday, your Docker?
Yes, yes.
Okay.
Yesterday it was completely okay.
You may just have to restart your PC.
Do you suggest to restart it?
Yeah, because
Well,
it
if it doesn't come up.
Sorry?
If it doesn't come up, then just restart your PC and hopefully that'll bring it up.
Okay, okay. I don't want to bore you in this.
No problem. So there's yeah. So there are a few things happening. So there's like a VM starting underneath, and sometimes it's possible that VM is like corrupted.
Now it's okay. No.
Yeah, it just takes a while. Yeah.
Now I try again.
So if you run that command again, yeah.
Yeah. Now it's okay. Sorry. Even if
it cannot fetch all the container images, right?
This one. And it seems that is due to my network, maybe.
Or maybe you don't have access to it.
That there are too many constraints or firewalls that prevent me.
Yeah, there's they are on a different direction. They are
Can you do an HTTP to that URL?
Yeah, also the
browser.
I don't think so.
If
Even
you can't,
because
then I'm afraid your firewall is blocking it, so there's nothing really.
Because otherwise I can switch. You see.
Has anybody else had this problem?
But I specify that I'm HP premises.
Yeah.
Check.
So if somebody else is not there, it's different.
Yeah, there's also a Grafana Grafana.
Otherwise, I can log in with my other network, that is my phone. Let's see if it works. Okay.
No, for me, from HP network, it started correctly.
So it's different point. So I don't know. Okay.
So I would try from your phone, but just be aware of the data usage because there's going to be about 1 gigabit of download. So
yes, it can be too much. Otherwise, another. Okay.
Yeah, I think that might be I think we can if you can pair up with a colleague and we try to get that troubleshooted afterwards might be worth. Is anyone else having problems like that?
Not for me.
Okay, so if there's no one else, then we can figure that out.
I also have an issue exactly the same as Alessandro. And I'm connected to the public network currently.
Okay.
That's something strange.
So we have at least like 2 people having that problem, getting container like the Grafana and the container images from the registry, right? Okay. Then I just give you like we go through that whole topic from my system. We go through the steps and then just chime in if you have questions or anything's going too fast or you want an explanation. Just let me know. So what I did here, I did basically stopped everything when you run a Docker PS. There's no container running anymore. So
you're not able to see your screen.
Please again?
You're not able to see your screen.
Share your screen, Ronnie.
Went away. So you see it again? Can make it also a bit bigger. You see it?
Yeah.
So so I stopped the whole stack with Docker Compose down. Checked if there's anything running.
I'm back. Sorry, I tried, but I was saying that I'm back and I tried to with another network, but it's not possible.
Yeah, we go through it here on my
Okay, perfect.
Just,
okay.
And just chime in if you have any questions or anything's
Yes,
unclear.
of course, no problem.
Don't worry.
Yeah.
So yeah, so Docker PS, nothing is running. We make a Docker compose up, run it in the background. So same thing, everything gets started. So what we have is basically, it's a bit explained in that README as well. So we have like the Postgres database. We have a volume for the configuration files for OpenNMS, a data directory where we have all these RD files and the time series metrics are persisted, so you don't lose that when you shut down the container stack. And we have Grafana deployed. And we have also 3 Linux agents, so to speak, like 3 servers with Linux running an agent on it. So if you run now the Docker PS, so you see now all these services are running. OpenNMS takes sometimes a while to start up. So when I try to connect here, so here we are. Default password is admin. We don't need our usage statistics sharing. We can disable that. And that is basically when you install an OpenNMS from scratch. So question number 1, what would we do to get our devices into OpenNMS? It's all about provisioning, right?
Yeah.
So what is useful before you provision systems, it's always helpful to have the SNMP configuration done first, because like provision D is relying on SNMP, right? It tries to gather these SNMP attributes like the system object ID, system location, system contact, the other IP interfaces, SNMP interfaces. So if you provision the device before you configure SNMP, you won't see as much as you would like. So I think it's good to know that before you provision devices, it might be useful to configure SNMP first, because provision D relies on it. If you say like we have an IP address, you can say something like we have what is the IP range here? I think we had here a little network here like 0.26. So you can say like for that range you can set you can even make the range bigger if you want. You can set a community for a whole range, and because the Linux systems are in the same network as the core system, we don't have many minions involved. We use the location default. That means the OpenNMS core system is talking directly to the agents. If you deploy minions with multiple locations, you can pick the locations here, so you can make more specific SNMP configurations.
What do you mean, Ronnie? By several minion locations? What is a location, in fact? Is it a subnetwork?
It can. So it's basically the characteristics of a location in OpenNMS is like you have a branch office, for example. So you have an OpenNMS in your data center installed, and you would like to monitor my devices here at home. then you would deploy a minion in my network here at home. You give it a location, Ronnie's office.
So we can say it's how to say it's a logical geographical location.
Yeah, it's kind of a so it's mostly a separated network, an isolated network, can be a security zone. It's most of the time where you have a when you have a core system deployed in a data center, and it's complicated to open, for example, all the firewall ports for SNMP, JMX, NetFlow, whatever, all the protocols you use for monitoring, you would have to open all these, or you would have to be able to make all these protocols available in your data center in the core. That's complicated at some point in time. So you have NAT involved and various firewalls. So
okay,
it's not easy to get all these management protocols back to your data center to a core instance, right?
I see.
And Minion can help on that because it can be deployed really close to the agents, and the communication is just a message broker, which is an easy TCP/IP connection, and everything goes through that like a tunnel, if you will. Makes it much easier to deploy or to get access to devices in remote locations. It also helps you, for example, with overlapping IP addresses. So my home office has the same IP range as Greg's home office, right? How do you solve that? Because and that's where the location comes into play. So I can deploy a minion in my home office, monitoring the same IP addresses as Greg in his office, because he has a minion in there, and the location and the IP address makes it basically unique for OpenNMS to deal with that.
And you can have more than one minion in each location if you want them to load balance between each other or provide a second minion as a backup.
Yeah, you can increase some resilience in that. If you have not just one minion in a remote location, you can have two. Yeah, that's true. Same for SNMP traps, for example. If you would like to, the SNMP traps, you won't send them over the internet to your core system in the cloud over UDP, right? It's not very likely that trap will come up there. So you can use like the local area network and the minion there as a trap receiver, and then it will take care of forwarding it to the cloud with more secure or reliable protocols.
Okay, Ronnie. Ronnie, I have a simple question. May I share my desktop,
of course,
please?
Yes, please do.
I have a small issue, I think.
Yeah.
Just tell me when you can see it.
I see, yes.
So in fact, okay, I executed Docker Compose from the stack folder, right? So pulling a lot of stuff. Okay, so far so good. And at the end, I got this. No space left on device.
That's seems like your Docker VM is running out of space.
Space, disk space, or
so yeah, if you go into Docker Compose, yeah, you have to not in Docker Desktop. Sorry, Docker Desktop. Docker Desktop.
Here I am running on the CentOS VM, not on my PC.
You have a VM installed. Okay.
Yeah.
Just have a look at df minus h again and see what memory you've got.
Yeah. So
maybe because of /var, maybe.
Yeah.
Yeah. Okay. So do you think I need to increase the /var partition?
/var so there's like in var, there's like the whole Docker, in varlib Docker, there's everything like the volumes, the container images, everything ends up in varlib Docker.
Okay,
and that
so
contributes a lot to your to the disk usage.
okay. I will unshare so that you can share again your desktop, but I will increase.
Yeah, you need to make
that disk partition.
Yeah.
You could also do a Docker system prune and clear out any images that you don't need anymore.
Ah, yes.
So
Docker.
Yeah, Docker space system prune -v, that will get rid of also the volumes. Yeah.
No. Okay, I will add.
You have to. It will only prune stopped container images. Everything which is running is still there. So, but yeah, but there's not. Yeah, you have to make that volume. Yeah, 16 gig is definitely not enough. Yeah, you need to make that definitely bigger.
Okay, I will. Okay, I have some disk available, so I will augment the partition.
Yeah,
Thanks.
sure, no problem. Yeah.
Thanks for your input. I will add at least 5 gigabytes for that partition for /var.
Yeah, probably more because just like the container image for Horizon is just like 2 gig already. So
okay. Thanks.
problem.
So sorry, it is taking
No
a bit more time in my case.
No problem. So okay, so yeah, we have SNP configuration was a topic. The SNP configuration is shared on multiple places in OpenNMS. So collecd will make usage out of that configuration. PolarD, ProvisionD, EnhancedLinkD, they all use these SNMP configurations to make or establishing connections to the SNMP agents. What a handy tool is the lookup tool, which gives you the possibility to figure out what SNMP configuration is used for a specific IP address. That's for troubleshooting very helpful. So you can say, if I have a device with that IP address in that location, you make lookup, and then it will tell you it will use version 2C. It's just a specific IP address. It's in location default, 1.8 seconds timeout, 1 retry, port, and all these things here, and what community is used, public, right? Okay, so in our case, like how the SNMP agents are configured, you get them with public. So the community is set to public, so you will get the information with the public community. Okay, so let's provision the device. Just call the requisition Linux server. So we add a node, call it Linux 01. Save that one. And so what is the IP address? It's that one here. So add interface. So here's an important piece. Anyone an idea what SNMP primary means? So if you have a router with multiple IP interfaces and you expose the SNMP agent on 2 or more interfaces, then collecd needs to know on which interface I need, or which interface should I use to fetch the metrics, right? So you have a router with 3 interfaces. Every interface you can get with SNMP. And now collect D, it doesn't make sense to collect all the metrics from all 3 interfaces because it's the same device, right? Why should I pick like for all 3 devices the CPU usage 3 times? Doesn't make sense. So in OpenNMS, there's a way to define like the primary interface. So that's usually your management interface where you want to make SNMP available. And then OpenNMS will try the primary interface, and you can also have secondary interfaces. And if the primary interface is down, then it will fall back to a secondary interface to fetch metrics from a different IP interface. So there's a bit of resilience in that if you have routers with multiple network interfaces. And if you put it to N, to not eligible, that means it won't be used for any SNMP communication at all. Any questions on that? So, so now we have the option to decide, do we want to force services on that IP interface, or do we want to make use from the provisioning detectors and see how and let provision D detect services. We can try to see what provision D comes up with. So we synchronize it. So that might take a while. So that's what we have so far. We have our Linux, the name comes from, that's the name from the SNMP agent. That is the name what we gave from provisioning, so that doesn't need to be the same. So that's what we told in the provisioning system to name the device, and that is what the SNMP agent told us. We have a system object ID and an ICMP and SNMP service. So if you look into the SNMP service, that's exactly the thing what we have seen in the slide. It's monitored with the Polar. The service is available, and we have a data collection associated with that service, which is an SNMP collector, and it tries to fetch all the metrics from that default collection set. If you look into the resource graphs, you will see exactly that collect D already does something. So so these two things here, SNMP node data and interface data, that comes from SNMP, from collect D and SNMP. The response time and the service status comes from Polar D. So Polar D is responsible for these metrics, and collect D is responsible for the interface metrics. So just have a look at it. We graph it, and then you will see pretty empty graphs because we just provisioned a node. So there's not much data here. You need at least like 10 minutes, like two consecutive data collections to get a point here, basically. So if we keep that running for a while, then you will see starting a point coming up. So what basically happens, the collect D tries to fetch metrics for TCP open connections. So that's already built in OpenNMS. So you don't have to take care of anything. So it's basically like a pre-baked configuration in OpenNMS already. And then you have like the network interface metrics, like bits in out, discards, and the default metrics for network interfaces. Okay. Just to look at these things here as well. So you have here like the ICMP response time. So that's when our Polar daemon pings a device. It measures how long what was the response time, and then graphs it as a response time graph here. And the status is it also collects like if the service is up, you get a 1. If the service is down, it persists a 0. So you get also kind of a way to look at a status over a time series chart, basically. It's just another way to visualize like the availability of a service instead of a percentage. Any questions so far? So to one thing what might help you is if you want like to edit configuration files, you can make
Ronnie,
yes?
is there a way to force on demand the get of SNMP, for example? If I want now to make a get, and not by command line, but by user interface.
The only thing you can do is you can use the Carafe shell to make a data collection.
Okay.
But it's not in the web UI.
Okay,
you need
perfect.
the Carafe shell for that.
I made this question because I was wondering whether Rescan was a tool useful on purpose. It's not. This is not.
No, it's yeah, that's you don't have a lot of influence on the scheduling of like the Polar or collect D. There's no direct influence to say like collect now.
Okay, so like if you want on demand or actual demonstration of what is happening, you have to do online by command line in the Carafe shell.
You need to use the Carafe shell. We can I can show you that. Just make a note the Carafe shell commands. Yeah.
Okay.
The only other thing you can do is you can do a rapid collection on a particular metric. I don't know, Ronnie, if you can show that, on the graph.
What do you mean by?
So when you go to a graph, you can select that you want to collect the metric every second rather than every.
You mean like the real time? Yeah.
Yes.
Okay. So yeah, that's a good hint. Yes.
Yeah, but this is either change in the sense that you have to change the configuration instead of doing this on purpose.
So yeah. So what here happens is like you have that little icon here on the top right corner, on the top right on the graph. It's they call it like NRT for near real-time graphing, and it fetches the same metric what you would like see here just every 10 seconds. You can go even higher, but some agents don't update the metrics regularly enough, and then you will see weird things like that. Because like the SNMP agent doesn't update the metric like every second on network devices. I think it's just like every 5 seconds is updated in a while. So it doesn't make sense to.
If you just demonstrate that, Ronnie, so she can see what it looks like.
So I just keep that running for like 10 seconds, and then. So if you make like 1 second here, you see that. So just update.
We can't see your.
Oh wait.
The pop out.
Maybe because it's the window broke it entire screen. Share. See it?
The source, of course, in this case are the RRND2 file, right? The RRND file.
Do you see my screen?
Yes, I see your screen. What I'm saying is that the source of this data in the graph are the RRND. They are stored there.
So yeah, so the so
okay, just
when
to know.
you click, yeah, so it seems like the screen sharing broke. When you go to resource graphs, you have here like the bits out metric. Then you have that little icon here on the top right corner.
Yeah.
That gives you that real-time graph. What I have here open, and it just fetches the same metric here. Not every 5 minutes. It does it like every 10 seconds. Right?
Okay.
And you can also
it's
say
actually
like
going out and doing an SNMP get every 10 seconds.
Exactly. It fetches these metrics from that graph every second, right? But sometimes, so the router or the SNMP agent on the router doesn't update the metric like every second. It just does it like every 10 seconds. And if you fetch the metrics in a too short interval, you see something like that here, like these spikes. That means you collecting the metric too often. You query the metric too often. So also the agent plays a part, like what is the minimal update interval for an SNMP metric on the router side.
So this data, so with the preferences, you are actually telling to the agent to give you, to change the frequency of the get. Is it?
So what happens is here, like if you change, so what OpenNMS does, it fetches the metrics every 10 seconds and just visualize it in that UI. It doesn't persist it on the file system. It's just for you in the UI. If you close that window, data is gone.
Okay.
It's just for you to
Okay, so here I can see, I mean, more frequent or on purpose frequency query.
Yeah, and that is here on that drop-down field. You can select how quickly you would like to get the metric.
Can we export this view in CSV file, for example? Or just down the way, sprints.
I think there's a data pane here, raw values. I think you can just copy it out from here.
Okay.
So if you keep that running like for an hour or something like that, then you have an hour worth of data here. But if you close that window, it's gone. You know what I mean? So it's really just something for ad hoc purposes. And it doesn't have, so the data collection underneath here, it just keeps working as it, so there's no interference here. So collect D does his regular job.
So Ronnie, does it save the data does it save the data for every 1 hour? Is it at the backend?
Collect D is taking care of that 5-minute interval and persisting it in RD. That here is just a pure UI thing. It basically it bypasses basically collect D completely. It goes like it just reads the configuration, makes the SNMP get with our SNMP framework, and just visualizes it in the UI. There's no persistence or anything happening, no thresholding, nothing. It's just like figuring out what the configuration for looks like for that graph, what OIDs are responsible to visualize that data and make that request every 10 seconds or 5 seconds, whatever you pick here. But it might help you instead of waiting 5 minutes to get here a line. It might be easier to just, if you have like a ad hoc diagnostics running, just looking at that way, it gives you a bit more responsible feedback. Yeah, what's happening.
And what I see is also that here green and blue are in average,
in
out
case,
average? What does it mean?
So that's a network interface. The interface is ETH0 in this case. That's the MAC address from that interface. They just concatenate it to make it unique. Otherwise, you can have multiple ETH0s for whatever reasons, maybe. Then we have bits in out. In that network interface, bits in is basically a positive and bits out is negative. And that gives you kind of an idea how much data is transferred over the network interface. And that compress means it basically, if you click compress, then you basically keep the starting point and just add data afterwards. If you remove that, then you have like a sliding window here, and it just moves through your screen.
I just want to confirm again, the data is not stored in any database, right? For long-term storage.
As it is by default, there's no there's like RD files in the file system as database.
But it's not permanent, right? RD file.
Let's
say I want to query like historical performance data.
Yeah, then you have, so there are two ways to do that. One is like querying with like these graphs basically, right? Because they give you they give you kind of a time window to look into, right? Another way is using the REST API. So we have a measurement REST API that allows you to query data like raw, similar data what you see here over REST endpoint.
Do you have an example of a REST API call for that?
Not yet, but we can.
I don't know. You know, via
going to cover Grafana at some point, and it actually generates the queries, so you can see the queries that Grafana generates.
Yes, exactly. So so basically, what we see here, you can do that also with Grafana, and it uses underneath our REST API endpoint, and that was what Greg was mentioning. It will make like REST queries against our measurements API to visualize it in a different place.
Okay.
But there's like another part is what Greg explained yesterday, that you might be interested to expose every metric collectee is collecting. It can also put it onto a Kafka producer on a Kafka topic, which you can consume on the other end instead of persisting it on a file system. So I think that was also something which might be interesting, but we should put into a later topic just to set like the foundation, how OpenNMS at least gets to metrics, I think. Yeah.
Can we customize the metrics which we want, which we are interested in? Only predefined metrics are there here, right?
So that's that's where we want to look into where is all that stuff defined, and how can you extend it, basically. So that's what we are coming next. So keep your question in mind, and if I don't answer it in the next 10 minutes, then break me.
Ronnie?
Yes.
For the lab 5 exercise, are we supposed running the container horizon as before? Because when I perform a Docker stats, I can see several services, several containers, except horizon. So I don't think it is normal.
It's called core.
If you want, can I share rapidly or?
Sure. Yes, please do.
The name is changed in this Docker Compose file to core. So in my Docker Compose, it's called Horizon, but in Ronnie's Docker Compose file, it's called core. It is running, but it's a different name.
It's, yeah.
Let me show you what I have. I just have this. So
then the core is missing for whatever reason. Yeah.
What is missing? Sorry.
So the core service is not in there. Yeah.
Exactly.
Yeah.
Exactly.
So just do logs. Logs minus f core core.
Yes, I have some issues. Yes, definitely.
Permission denied for the so you have to change the so you have to make the you mounted the configuration files in a local storage, right?
Yes, let me show you.
So you need to make sure that the owner is the user ID 10,001.
Oh.
So the OpenNMS process in the container runs as user 10,001, and you have to make sure that your files which you mount into the container have the same owner.
How can I fix that? How can I check?
Just make an ls and your etc directory, core etc, you have to make it shown on 10,001. All the files in there need to be, that's the reason why he cannot create any files there, because the core etc directory is owned by root.
Oh, yes, correct.
Change owner,
okay, yeah.
And then 10,001 colon 10,001. No, 10,001. Use the
sorry,
10,000, 10,000,001. Yeah. Colon 10,001 again. Yeah. And then the core etc with -r for recursive. And you have to add please in front of it. Yeah. And then it works. Yeah.
So now what should I do? Shut Docker Compose down and Docker.
No, just Docker Compose up is fine, because it will just start the core container. There's a
Sounds better.
So now it creates all the configuration files in that directory. Now you have it there. Yeah.
Oh, okay. It takes a while, right?
Yeah, it like on the first run, it initializes the configs and it sets up the database schema, and so that's the reason why it takes a while to start up. And now
it is a bit verbose. Is it normal that we have everything on the standard output here?
In Docker, it's pretty normal to have, because that gives you kind of a flexibility where you would like to log stuff into. So the Docker daemon allows you to redirect logs to file system or external log.
That's because I did not specify the -d option. Okay.
Yeah, and because of like in a Docker container, there's only just one process running. They just drop everything on standard out. There's nothing. So normally in a container, there's not more running than just one process.
So no, and if I want to get rid of these standard output traces,
you make just Docker Compose up -d that runs it in background.
That way?
Yeah. And
okay.
That's
okay.
it.
Okay, and now. Okay, I have the core. Okay, I have the core. All right, thanks.
No problems.
Okay, I unshare.
So,
can you remind from where we can run SNMP walk, or if we have to install it somewhere?
So the SNMP walk you can install. You can run from like if you have a Linux system, you need to install the SNMP utils.
Okay, we can do it in the core, or it will not be working.
In Windows, I think I'm not sure if there's a SNMP yet.
Okay, we have to install it from the external.
Is it on one of the containers, Ronnie?
So in the
examples, have you got it there?
I think if you exec into the Linux container, there is the SNMP walk installed. The Horizon Core container is also very limited, so there's not much installed in there. So they are really
Docker Compose exec
Linux
exactly. 01 dash. Try that and then do the walk there.
Exactly. So
just a timing thing, Ronnie. We've got 15 minutes left. Is there more stuff you want to cover now, or do you want to just consolidate and come back on Thursday?
So I think it might be useful to have everyone at least on the stack up and running, have the node provisioned. I think if we can make that happen to get like barriers out of the way, and then we can continue on Thursday. Yeah.
Okay.
Today we have like a point where we can continue and everybody is on the same spot. Does anybody have issues with getting that stack up and running and get that node provisioned? So so is everybody able to get to the web UI to do like the provisioning of the node? Is anyone blocked here?
No, it's okay for me.
I have a difficulty to run the exec Docker Compose exec. It says that the
Share your
service
screen
is
and then
not.
we figure it out. Yes.
It's not. It says it's not running when I run the exec, so I'm not sure.
Yep. Just share your screen and then.
Yes, I'm sharing.
Yeah. See. So that's.
Hold on a second.
Yeah.
I need to find the share screen button.
Okay, see your terminal. You're in
at the bottom. At the bottom.
It's what I'm seeing
Green
is
button
right
at the bottom.
Deploy _AA in that window. That's what I'm seeing.
Is not running.
Now it's something else comes up. Yeah.
So I'm not sure. I can share my whole screen. By the way, it will be better.
Just core. You don't need exec stack core 1. Just core. Docker
just
Compose
core.
exec.
Yeah, you can use when you use like Docker Compose, you just use the service name as it is in the compose file,
well,
and then you.
Okay.
If you are not exact, it's going through. Okay.
It's basically it takes the name from the compose file. If you look into the compose file, you see all the services.
Okay.
And it takes that name.
I got it. Okay, thank you.
And if we can just go out of the core image, we can try that SNMP walk if you want to. That's a good example. So Docker Compose exec, go to that Linux 01, for example.
So Linux 01.
01, yeah, and then bash. Or sh, I think it's just there's just an sh in it. And then try to run SNMP walk. Yeah. No, it's not installed as well. So yeah, the packages are not there. It's an I think that SNMP agent is based on an Alpine Linux.
Okay.
It doesn't have apt installed.
Great.
APK you can use.
But what you can use is the Carafe shell. Go out of that container. So you can use the Carafe shell from OpenNMS. you can access it with SSH, SSH space admin.
Yes.
Admin at localhost -p 180 no, sorry, 8101.
This one?
Yeah. So the password is the same as the admin passwords, which is by default admin, and then you have a SNMP walk command.
Okay.
You just hit the tab key. It has an autocomplete. So just type SNMP and hit the tab key, and then you will get suggestions like SNMP walk, right?
Okay.
So
I can.
And then you make a --help just to and that gives you kind of an idea.
Okay.
So -L for location, for example. So you want to make an SNMP walk for a node in location default, -L space default. I think default has a capital D. And then you have to put in the IP address.
I would have to get
192, 168. And then you have to look into the README, I guess. It's 42.33 or 32 or something like that. Yeah.
I have it. It's .34.
Yeah, just hit enter, see what happens. He needs an OID, so you have to provide an OID. Just make it .1, for example.
.1. Okay, that's the poor man's OID. Okay, it does the whole tree.
Yeah.
Okay, great.
So and what it does, so I think what you might miss is where's the SNMP community? Where is the version, right?
Mm-hmm.
You haven't specified it, right? But it takes it from the SNMP config XML from your system. So it really pretends what OpenNMS will do when collect D is going out and tries to get these metrics. It uses exactly the same SNMP configuration for that location and that IP address.
So each line here does correspond to one specific metric, right?
So now that's basically where you need the MIP from the vendor to tell you exactly how this tree looks like.
Yeah. But
how to interpret
each
these.
OID we can see here from that window to correspond to one metric, right?
Exactly. Yes.
Okay. We don't know yet the meaning, but we know that all of these are different metrics.
Okay. Right. And if you use that from that README, if you use like that these load metric, then you will see exactly these three values there. If you go into the README.
And as of yesterday, during the previous exercise we did yesterday, we need to import the vendor MIB into OpenNMS, and then it can decode.
So there are various ways. It's pretty similar what we did yesterday. When you receive a trap, you need a way to make sense out of that trap, right? And that's where you need the MIB. In OpenNMS, it's a similar thing for data collection. You can generate from a MIB. You can generate the configuration file for collect D the same way. The problem is like MIBs are usually like they are so huge and there are so many things in there, and sometimes even the device doesn't support all the metrics. So if you just go out and just import every MIB you find and every metric you find, you will hammer the SNMP agent with a lot of stuff because there are like thousands of metrics in there. So there is kind of a need to investigate what metrics of that MIB you wanna collect. Because that's also like, just assume like fetching like thousands of metrics from an SNMP agent, you have to persist them for a long period of time as well. That needs to be somehow maintained. So I would say there's a price tag attached to all these metrics, kinda. So you need to be careful what metrics you collect and do they make sense for the use case.
I understand. One last question, Ronnie, here.
Yeah.
Still from that screen, we can see the -L default option for the SNMP work command here. So -L, I guess it means location, probably.
It's true, yes. Yeah.
But does it mean that SNMP work knows about the OpenNMS locations, or is it a location that has nothing to do with OpenNMS locations?
That is exactly the OpenNMS location. So what you are making is you're using basically the mechanisms of the SNMP configuration, what we did in the UI before, where you configure like SNMP communities per location and for an IP range. It basically tries to query that OID with that SNMP configuration you provided.
Yeah, I question you about that because for me, SNMP work is a utility that is not delivered by OpenNMS.
This is delivered by OpenNMS. This is actually
so you are in the Karaf shell. So
it is delivered.
Yeah.
Okay.
So that SNMP walk, it just has the same name. But it's not the SNMP walk binary from NetSNMP. It's an OpenNMS SNMP walk.
I see.
So
it's wrapped.
And that is shipped in the Karaf shell, and it behaves similar like the SNMP walk, but it uses completely our configuration and our node inventory, and it just lets you troubleshoot what would OpenNMS do if we want to talk to an SNMP agent in a certain location.
Okay, that's clear.
Okay.
It looks like the SNMP work
it's on purpose
from Linux, but
know how that looks
it
like.
is better.
We expect certain behavior, so that's the reason why, and even why it's called SNMP walk.
Okay.
Sorry about that.
Okay, thanks.
Okay.
I'm sorry, for me, I'm having this issue. Yeah, it says that.
Sure.
Still on port. It says that this port
It has
already...
a problem to allocate to assign the port 8980 on your local system. So it looks like your port 8980 is somehow already bound.
Did you do Docker compose down on the previous example we did last week?
If you run a Docker PS, you will see everything which is running. It gives you kind of the whole process list, and it looks like they are like there's already there's also a minion running. So there's few things running, and that and there you see that on the OpenNMS. So there's already a Docker stack running. That is the problem. Where is it? Question is, from which directory have you started that one?
That's probably running from your previous example.
Yeah.
That means I should stop the other one first, is it?
Right, yes.
Yeah.
Through the Docker compose down -v.
So you have to go back into the directory from Session5.
From Docker Desktop, it's easy. Also, you can stop it from Docker Desktop. You can see the previous one. I did it previously.
Because in Docker Desktop, as I see here,
if you go to containers,
not images, is container.
And you have lots, but you probably have the one from yesterday. This one, was from yesterday.
The one is from my other exercise. Okay.
You can
Sorry,
stop the
I
whole
didn't know
container.
this. Just stop it here, right? Okay. Because initially I thought it was images. I saw images. All is already stopped.
So there are like so there's different states. So you see that like that minimal minion active MQ stack that is running like 3 hours ago. If you select it, like if you select the whole thing, the checkbox on at the beginning.
Here.
You hit that check. Exactly here. That means all containers in that stack, and then you can stop them or delete them or whatever. Yeah.
Okay.
So now you should be able to run it
Yep,
because
yep.
they all exited now.
Okay, I think it's good now.
Yeah, that's definitely something. If you provide for every exercise in your own stack, you need to make sure that they don't run.
Okay, sure. Think
Otherwise,
settle. Thank you.
Okay, so we've reached 11 o'clock, so I think we probably need to stop now. First thing I want to say, Ronnie, thank you very much.
No problem.
It was very helpful. You'll be back on Thursday, carrying on with more of this. Obviously,
just continue
carry on with the examples. And I'll be doing more on fault management tomorrow. Are there any last questions before we go?
Yeah, but one question. Is there foreseen some train machine related to threshold settings for threshold configuration?
Again, please. Is there
threshold,
what?
do you hear me?
Yes, I hear you.
Okay.
Yeah.
Besides getting matrix, I know implementation OpenNMS also is equipped with functionalities related to threshold.
Yep.
Is it foreseen some lesson related to threshold configuration?
Yes.
Okay.
Yep.
That's it.
Thank you. I can add that topic as well on Thursday.
Very interesting also because there are some, grammatics to understand, to be understood.
Yeah, sure.
Yeah. Okay. Very nice.
Yeah, no problem.
Really interesting. Very, very.
Enjoy your day.
Grazie.